ಸಮಸ್ಯೆ ಕೊಡಕತ್ತ ಸಮಸ್ಯೆ Good afternoon to everybody. ಪ್ರಪ್ರಥಮವಾಗಿ ಶ್ರೀ ಬಸವೇಶ್ವರ ವಿದ್ಯಾವರ್ಧಕ ಸಂಘದ ಮೂಲ ಸಂಸ್ಥಾಪಕರಾದಂತಹ ಪರಮಪೂಜ್ಯ ಶ್ರೀ ಬೀಳೂರ ಕುಲಸ್ವ ಮಹಾಸ್ವಾಮಿಗಳ ಪಾದಾರವಿಂದಗಳಲ್ಲಿ ಕೊಡಮಟ್ಟು ಇವತ್ತಿನ ಈ ಸೈನ್ಸ್ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಹಾಗೂ ಸ್ಟೂಡೆಂಟ್ಸ್ ಕ್ಲಬ್ ವತಿಯಿಂದ ಹಮ್ಮಿಕೊಂಡಂತಹ ನ್ಯಾಷನಲ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಡೇ ಅಂಗವಾಗಿ ನಾವು ಉಪನ್ಯಾಸಕರನ್ನು ಏರ್ಪಡಿಸಿದ್ದೇವೆ. ಹಾಗೂ ಅತಿಥಿ ಉಪನ್ಯಾಸಕರಾಗಿ ಪ್ರೊಫೆಸರ್ ಡಾಕ್ಟರ್ ಶ್ರೀ ಎಸ್ ಬೆಂಚಳ್ಳಿ, ಹೆಡ್ ಆಫ್ ದ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಆಫ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್, ಬಸವೇಶ್ವರ ಇಂಜಿನಿಯರಿಂಗ್ ಕಾಲೇಜ್ ಬಾಗಲಕೋಟೆಯಿಂದ ಅವರು ಆಗಮಿಸಿದ್ದಾರೆ. ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮದ ಅಧ್ಯಕ್ಷತೆಯನ್ನು ಶ್ರೀಮತಿ ಜಯಶ್ರೀ ಗದ್ದಿ ಮೇಡಮ್ ಅವರು, ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಸೈನ್ಸ್ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಅದ ಮುಖ್ಯಸ್ಥರು, ಕೋಆರ್ಡಿನೇಟರ್ ಆದಂತಹ ಶ್ರೀ MK ಚೌಡಿ ISTE ಸ್ಟೂಡೆಂಟ್ಸ್ ಚಾಪ್ಟರ್ ವತಿಯಿಂದ ಅವರು ಉಪಸ್ಥಿತರಿದ್ದಾರೆ. ಅದರಂತೆ ನಮ್ಮ ಇನ್ನುಳಿದ ವಿಭಾಗದ ಉಪನ್ಯಾಸಕರಾದಂತಹ ಶ್ರೀ GS ಶಿವಭಕ್ತರ್ ಸರ್ ಅವರು, ನಂತರ ಶ್ರೀಮತಿ ಬಲಸಾವಿ ಮೇಡಮ್ ಅವರು, ಶ್ರೀನಿವಾಸ್ ಅವರು ಎಲ್ಲರೂ ಆಗಮಿಸಿದ್ದಾರೆ. ಎಲ್ಲರಿಗೂ ನಾನು ಬರಮಾಡಿಕೊಳ್ಳುತ್ತಾ ಡಾಕ್ಟರ್ SS ಬೆಂಚಳ್ಳಿ ಸರ್ ಅವರನ್ನು ಪರಿಚಯಿಸಲಿಕ್ಕೆ ಬಹಳಷ್ಟು ಉತ್ಸುಕನಾಗಿದ್ದೇನೆ. Dr. Sivalingappa S. Benchadi, he was born in 1/8/1963 and he has completed his graduation, next post-graduation from Karnataka University in 1990, and he has completed MPhil degree from Karnataka University in 1998. Afterwards, sir has completed PhD from Karnataka University, Dharwad in 2006. Sir has started a journey of his career in the Micro Finished Pumps Private Limited, Hubli, which is a leading industry in Hubli. And in the tenure of 1989 to 1990, he has worked as a programmer in software development. Afterwards, Professor has joined as a lecturer in BC Javin Science College, which belongs to KLE, Hubli, from 1990 to 1997 as a lecturer, and he has taught many subjects. Afterwards, sir has joined Basveshwar Engineering College, which is our sister institution, from 1997 to 2002 as a lecturer, and he has started teaching for engineering students. Afterwards, Professor has joined, he has been appointed as a senior graded lecturer in 2002 and up to 2006 he has worked. Next, sir has promoted as an associate professor and head of the department of mathematics in Basveshwar Engineering College, Bagalkot, from 2006 to 2015. Next, from the associate professor, sir has promoted as a professor of mathematics department from 2015. Then Professor Benchadi sir is working from 10/12/2018 as a professor and as a head of the department of mathematics. So he is having an outstanding career developments. And sir has completed his PhD, that is particularly thesis is the computations of effect of rough surface on lubrication characteristics with application topology. And the title of his dissertation is that is computation and applications. So having the different interest in the areas, the particularly area of interest are numerical analysis, fluid dynamics, fractal geometry, complex analysis, computer science, and GeoGebra. And sir has published many papers in the national level and also in the international, totally 11 papers. And he has attended many conferences right from the STTP and workshop, national seminars, conferences, and international. In total, sir has completed 24. He is having membership for different bodies, that particularly professional bodies. Sir is the life member for AICTE New Delhi from 1998 up to date. Sir is the life member for Karnataka Rajya Vidyana Parishad 2005 onwards. He's having a uh, super created various ideas that particularly applies and uploaded in the GeoGebra website. And sir has given some of the topics in the YouTube channel creator, that is BECMA BMAT 16, which has created various short videos on engineering mathematics. So sir is invited by different education organizations. Totally 30 organizations have invited sir. So very progressive milestone of any teaching profession person. He is a member in board of departments for 5 times, organized a national conference and a CTP 5 members, has completed the entire, that is a VTO doctoral committee member as a domain expert. Sir is a BO member for mathematics department from VTO Bagalkot, and is BOS member for computer science engineering for the academic year 15-16. And he has designed a successfully and implemented syllabus for mathematical model in open elective subject for 5th, 6th, and 7th semester engineering course from the academic year 2011 onwards. So, from this, sir is having an outstanding personality in the field of mathematics. So, such a great person we have invited, and on behalf of our principal, Sri G.B. Shetty sir, on behalf of the HOD of Science, Srimati Gadi Madam, and all the staff members, I cordially inviting, welcoming Dr. S.S. Benchedi for this mathematics forum. I am requesting Professor Mathematics, so Professor Benchedi sir, to give your presentation on the mathematics for our students. So please. So on the behalf of Science Department, I am requesting Srimati Gadi Madam to honor Professor Dr. S.S. Benchedi sir on behalf of the department. Sir, please.
So thank you very much, sir. Your nice words. So first, before starting, I want to wish all the students community to happy National Medics Day. So today is 22nd December. It is a special day for all the Indians because the Indian government declared 22nd December to be a National Mathematics Day. This was announced by former Prime Minister Manmohan Singh on 26th February 2012 at Madras University to mark the 125th birth anniversary of the Indian mathematician Srinivas Ramanujan sir. I think Ramanujan sir born on 22nd December 1887 at Erode in Tamil Nadu. Now I hope all of you are observing Ramanujan's birthplace on 18th Alhari Street, Erode. So it is in Tamil Nadu. Now I hope you are able to see Ramanujan's home on Sarangapani at Kumbakonam. Okay, now you are able to see one more picture and you can see the Ramanujan sir at the center and his colleagues. Okay. So later he joined Trinity College at Cambridge, obtained the degree. So it is another picture, Villa Industrial and Technology Museum at Kolkata. So Indian government created a stamp, his name Ramanujan at 2011. I hope all of you are observing his signature, right? He obtained a Fellow of Royal Society award, right? So during his short life, Ramanujan independently compiled nearly 3,900 results, right? So in the year 1919, due to ill health, he came back to India, where he died in 1920 at the age of 32. Okay, with this brief introduction, now I am going to introduce one tool, namely GeoGebra. Before going into a GeoGebra, I want to start a talk with a small quotation. Past is experience, present is experiment, and future is expectation. I hope all of you are joining this course with the previous experience. You can use your experience, right? In this college, you can treat it as an experiment. If you've done well, then you can expect a better future. I wanted to share and one more quotation. True guidance can be a small lamp in a tunnel. It does not show everything at once, but it gives enough light for next step to be safe and sure. Okay. The goal of this lecture is to familiarize GeoGebra. You may ask what you mean by GeoGebra. Thank you. The objectives of the talk are to enhance teaching and learning of mathematics, to move students towards higher levels of understanding, to develop students' understanding, stimulate their interest, and increase their proficiency in mathematics. Right? So you may ask why we want to study GeoGebra or why we want to study Scilab or MATLAB. As I have mentioned, it's a tool like Scilab or MATLAB. I hope you're already familiar with MATLAB or you're already familiar with Scilab. So like that, GeoGebra is also a tool, right? Okay, so now you are observing the goal gumbaj. Now I want to calculate volume of the dome. Volume of the dome of the goal gumbaj. How I am going to calculate it? So I can say that so using GeoGebra, you can calculate the volume of the dome, right? So it doesn't mean that without the GeoGebra, is it not possible to calculate the volume of the dome? Yes, it is possible. But if we calculate using GeoGebra, so you can understand in a better way. Or this is one way to calculate the volume of the dome, right? Now, I want to take on another problem. So, for example, now I want to manufacture or want to manufacture a bulb, right? A manufacturer of kitchen equipment produces different types of plastic bulbs, right? Or I hope. So is it visible? Yes, sir. Yes, sir. Is it? I hope. All of you are saying it is a mug, right? Now I want to generate this type of a mug, or I can say that it is a teacup, right? So I want to generate a teacup. How I am going to generate a teacup, right? The plastic balls have all been generated from rotating a cup, right? So it is a cup. So in mathematics, I can see a curve. For me, it is a curve. How I am going to generate this mug or teacup? I hope you are seeing a curve, right? It is a curve. Suppose if I rotate this curve around the y-axis, right? So this will generate the ball, right? Just I will rotating slowly. I hope it is visible. Suppose if I increase the speed, so this will generate the value or this will generate the power, right? So now I want to calculate the value. So how I am going to write down this curve in mathematics? Basically, that is important. So you may call it as it is a mathematical model, right? The balls are based on the exponential function. I am going to use a very simple function, namely exponential function. How I am going to write down? All of us know that a into e to the power b into x, where a and b are some constants, right? So as I have mentioned, so this curve is rotated around the y-axis. Basically, if I rotate this curve around the y-axis, this will generate the ball. Now I want to calculate the volume. How I am going to calculate volume? So using integration, right? So now I want to integrate, right? So what I want to integrate? I want to integrate a function. How I am going to denote that function? Say some function p of y with respect to y. So you may ask, p of y represents what it represents. So is the area of the circular cross section area at the height of y. At the height of y means, so I am going to rotate this curve around the y-axis. I want to take minimum value at y and maximum value at y. So here in this example, they have given a specific value. As a specific value means the plastic bowl should have an inner height of 10 centimeter. So height of the bowl should be 0 to 10 centimeter. How we are going to solve this problem using a tool? So before that, you assume that they have given some coordinates for a future ball. We are going to generate a ball. Is it clear? So they have given x values, y values. What they have given? They have given x is equal to 0.1 centimeter. Corresponding value of y is 0.007 centimeter. 0.5 centimeter. Corresponding value is 0.011 centimeter. So like that, they have given 0.1 to 6 centimeter, corresponding value of 8.371 1 centimeter. So as I have mentioned, so what I want to calculate, I want to calculate the bowl's inner volume, right? Then without changing the inner width and height for the bowl, determine suitable values for A and B. Here A and B are constants. Now I want to calculate the values of A and B such that the volume of the bowl is exactly 1 liter. So for example, now I am showing a tea cup, right? So I want to calculate its volume. It should contain exactly 1 liter. ಇದು ನಮಗೆ ಟೀ ಕಪ್ ಏನ್ ಕಾಣಿಸ್ತಾ ಇದೆಯಲ್ಲ, ಈ ಕಪ್ ಒಳಗಡೆ ನಾನು ಏನ್ ಮಾಡ್ಬೇಕು ಅಂತಂದ್ರೆ 1 ಲೀಟರ್ ವಾಟರ್ ಅಥವಾ 1 ಲೀಟರ್ ಟೀ ಹಿಡಿಬೇಕು. ಹಂಗ ನಾನು ಏನ್ ಮಾಡ್ಬೇಕು, ಐ ವಾಂಟ್ ಟು generate this bowl or this mug or this jug. How we are going to generate this, right? So as I have mentioned, using the GeoGebra, it is possible to generate. So before generating, first I want to write down the equation for the data. What is the data? So this is the data. So you assume that we have conducted an experiment. From the experiment, you will get a data like this. Now, how I am going to write down these data in the form of equation? Is it clear? Okay. First, I want to type all the data in this GeoGebra, right? Then you want to draw the graph. I hope you'll get a graph like this. Just a minute. I am going to open the GeoGebra file. I will show you how I have drawn this diagram. You will come to know. It may take 1 or 2 minutes to open that file. Simply you want to type. So it is containing an Excel sheet. I hope you are already familiar with the Excel sheet. In Excel sheet, you want to draw the data, whatever I have shown, means you want to type X values as well as Y values. Then if you select that data, I hope automatically GeoGebra will draw all these points. I hope it may take more time. I don't want to waste your valuable time. I will move into the next. Okay. Yes. So this is GeoGebra. When you are going to open GeoGebra, I hope this window is called a graphic window, right? So what you are observing, these are the points. So I have typed X values as well as Y values, right? So you can see an algebraic window. So you will get each and everything in algebraic window. So corresponding graph. Okay. Right? Now exactly in the similar way. So at the problem they have given, the height of the mug should be 10 centimeter, right? What I will do in GeoGebra, I will type y is equal to 10. I hope you'll get a line, what you are observing on the graph. You will get a straight line parallel to the x-axis. So this looks like a mug, or this looks like a bowl. Is it clear? Right? So I hope you are observing these points. You can take the mirror image of this part of the curve. You will get this part, and y is, you can type y is equal to 10. You will get a straight line, and you can intersect these two curves. Is it clear? Then I will get the width from the y-axis, right? So from the y-axis, 6.15 comma 10, because they have given height of the mug or bowl should be 10 centimeter. I hope it is clear, right? So now you are observing the equation. F of x is equal to 0.01 into e to the power 1.24 times of x. So in the GeoGebra, automatically you will get this curve. So it means it's understood that we have generated an mathematical model. How we have generated using the tool, namely GeoGebra. right? You can verify. So whether is it whatever we have generated, no, is it correct or not? That can be verified. Okay. So after that, what I want to do, I want to calculate cross-sectional area. How I am going to calculate cross-sectional area? I hope you are observing this teacup, right? So I will place a plane on this cup, right? So what you will get, it looks like a circle, right? It looks like a circle. It means I want to calculate cross-sectional area means pi r square, right? With the little mathematics, it is possible to calculate cross-sectional area. I hope we'll get 0.69 times of pi into natural logarithm of 161.3 times of x whole square. So this is the formula for cross-sectional area. So I will get the value, right? So here for the convenience, I have considered x axis as y axis in centimeter, right? So y axis as another axis, right, in centimeter square. I hope I will get the value. I have calculated volume. So what is the volume? 908.3. Is it clear? Right? That means approximately it is a 0.9 liter. Right? So we have generated a mug and I have calculated volume. What is the volume? 908. But our expectation is exactly 1 liter. Then what I want to do, without changing the parameter, without changing the dimensions, now I want to make it as 1000 ml or exactly 1 liter, right? So how do we make it? Using the tool. Is it clear? Right? So height is 10 centimeter and width, I cannot change the width. Width is 6.15. One side, other side is also 6.15. So I want to change the equation. I want to change the equation. So this equation represents data, whatever data we have generated or whatever data they have given. Is it clear? Now I want to multiply this equation by an exponential function e to the power dx. Then you have to simplify. Then you will get one more curve. So what you are observing on the graph sheet, you will get there is a slight difference between these two graphs, both of the sides, right? Okay. So once again, you have to calculate cross-sectional area. So it is possible by changing the parameters a and b in the earlier equation, what I have shown. So f of x is equal to a into e to the power bx, right? So I have to change the value of b, right? So by changing the value of b, I can change the value, right? Yes. Just a minute, I will show you. Okay, I have created a slider. So here B is the slider. Now I want to change the value of B. You can observe the graph, right? The volume of the curve will change automatically. Now the value of B is equal to 1, right? Okay. So now the value of B is 1.2, right? It coincides with the original curve. Now it is crossing the original curve. Now the value of B is 3.8, right? So now you will get more value. Is it clear? You will get more value. But what we are expecting, we are expecting exactly 1 liter, 1000 ml. For that reason, what I want to do, I want to decrease the value. Sorry, decrease the value of P. So when I am going to set 1.9, right? I hope we'll get the exactly 1 liter value, right? So again, I have to calculate cross-sectional area for the new curve. I have to calculate cross-sectional area for the new curve. As I mentioned, if I want to generate a new curve, I have to multiply by an exponential function e to the power bx. After simplification, I hope we'll get this curve. So this is the new curve equation, right? So I will show you next slide. Okay. So I have calculated cross-sectional area again by using a little mathematics. Now you are observing 1000, right? The volume of the mug is 1 liter. How I have calculated it, you will come to know. So by using this formula, so I have calculated it. So you can observe B is equal to 1.9. If you want, you can change, right? Now you can observe, right? The value is automatically changing because B is 1.5. If you want, you can move automatically. It will change the value of B automatically. You can observe. So the value is changing, right? So now the value is 951 ml, right? So like that, if you want, you can change the value of B. I hope it is clear. So we cannot do all these things on the blackboard. So this is the advantage of technology. This is the advantage of GeoGebra. Just a minute. I don't know. I want to show you one video. There, able to open. How we can generate a bowl, you come to know. Yes. I have downloaded this video from the YouTube. This video is available in YouTube, right? So using a GeoGebra, it is possible to generate a bowl. You can compare with the real bowl. You can compare with the real value. You can take your own bowl in your home, then calculate the value. You can generate the same bowl using a software GeoGebra. Yes, it's a beautiful video, right? This video is available in YouTube. If you want, you can download or you can see afterwards also. What is the equation of the bowl? So this is the equation, right? One more video is there. I wanted to show you. Is also available in YouTube. So you can generate just by typing one equation. You can generate a surface like this, or you can generate a bowl by using this function, right? So you can compare with the real bowl. You can also create this type of videos and you can upload. Yes. It coincides with the real bowl, whatever we have generated. So that is the advantage of the tool. Okay. I hope it is clear. Why we want to use GeoGebra? I hope now you will come to know an idea. All right. Now I want to take another real world problem. Right. So in physics, we are going to conduct an experiment. What type of experiment? We can assume that a lead ball is dropped from a height of 5 meters. The students record the distance the ball has fallen every 1/10 of a second. This can be done by using a camera and the strobe light. So for example, you assume that this is the ball. Now I want to drop the ball. Right? ಈಗ ಒಂದು ಬಾಲ್ ತಗೋತೀನಿ, ನಾನು ಅದನ್ನ ಏನ್ ಮಾಡ್ತೀನಿ, ಕೆಳಗಡೆ ಬಿಟ್ಟು ಬಿಡ್ತೀನಿ. Is it clear? So now I want to calculate what is the position of the ball after some seconds. Is it clear? Right? So that is the idea. That is the experiment can be conducted in the physics laboratory. Right? Here what I want to do, I want to make a scatter plot of the data. How I am going to conduct an obtain an equation using GeoGebra. It is possible to find out the equation. right? So now I am going to use the model to predict how far a drop of a ball would be or would fall in 3 seconds. Okay. Here we have a data times 0.1 second, 0.048, 0.2 second. So how we get this data? Using that we have conducted an experiment in the physics laboratory. We have obtained the data. Now when what the ball between 0.1 second against distance cover the 0.048 distance. After 0.2 seconds, it will cover 0.197 meter, right? Time in seconds, distance in the meter, and so on like that. They are done. After 1 second, it will cover 4.902 meter. Basically, now I want to calculate after 3 seconds what is the corresponding distance. So we want to calculate, right? Here, there are so many methods to calculate or to solve this problem. Whenever you are going to join an higher study, so we can study or we can calculate the value of y. Suppose if I treat all these values as x, distance as y. So by using the Newton's method, it is possible to calculate mathematically, right? Here, I am not going to use that method. By using GeoGebra, it is possible to calculate the value of y corresponding to 3. Okay, so as usual, I want to draw this data in the Excel sheet and I am able to draw the graph. I hope you will get a graph like this and you will get an equation also automatically from the tool. So what is the equation? F of x is equal to 4.96221 into x to the power 2.00269. You will get an exponential equation. Your x-axis is treated as time, y-axis is treated as distance. That's clear, right? So now I want to calculate after 3 seconds. So in this equation, now I want to replace x by 3, right? I hope I am able to obtain 44.7921 meters. That's clear. Okay, so you assume that. So we have calculated all these things with the help of a tool. Right? So how do you say that whatever we have calculated is correct? You want to verify. This is clear. Right? How do you verify? So here we have conducted all these data from the experiment. You assume that we have conducted an experiment. From the experiment we have obtained. So if you want, you can calculate for 0.2 for 0.2 seconds. What is the corresponding distance? Or you can enter x is equal to any number 0.8. 0.1 or 0.9 or 1, you can verify. On the basis of that, you can say that whatever we have calculated is correct or not. Not necessarily in 3 seconds. For any value, you can calculate corresponding distance. I hope it's clear. Right? Okay. I want to take another problem. Stocking a pond with catfish. Right? So they have given much of the fish that is sold in the supermarkets today is raised on commercial fish farms, not caught in the wild. A pond on one such farm is initially stocked with 1,000 catfish, and the fish pollution, and the fish population is then sampled at 15-week intervals to estimate its size. The population data are given in the following table. I will show you the table. It is there in the next slide. So what we want to calculate? We want to calculate, find an appropriate model for the data. So we have a data. I want to write down an equation. Make a scatter plot of the data and graph the model that you found in part A on this scatter plot. How does the model predict that the fish population will change with time, right? So I hope all of us are familiar with the fish. Again, market ಒಳಗಡೆ ಏನು ಫಿಶ್ ಸಿಗ್ತಾವಲ್ಲ ಅವೆಲ್ಲ ಫಿಶ್ ಹೆಂಗಪ್ಪ ಅಂತಂದ್ರೆ ಎಲ್ಲರ ಒಂದ್ ಕಡೆ ಬೆಳೆಸಿರ್ತಾರ ಅವನ್ನ ತಗೊಂಡು ಬಂದು ಮಾರ್ಕೆಟ್ ನಲ್ಲಿ ಸೇಲ್ ಮಾಡ್ತಾರಂತ ಇದು ಸರ್ವೆ ಹೇಳ್ತಾರೆ. ರೈಟ್? ಎಲ್ಲಿ ಬೆಳೆಸ್ತಾರ? ನಮ್ಮ ಇಂಡಿಯಾದೊಳಗಡೆ ಐ ಹೋಪ್ if you observed, ಏನು ಒರಿಸ್ಸಾ ಅಂತ ಏನಿದೆ ಅಲ್ಲ ಒಂದು ಸ್ಟೇಟ್, ಒರಿಸ್ಸಾದಲ್ಲಿ ಏನಿದೆ ಅಂತಂದ್ರೆ ಮನಿ ಒಳಗಡೆ ಒಂದೊಂದು ಪಾಂಡ್ ಇದೆ. ಆ ಪಾಂಡ್ ಒಳಗಡೆ ಅವ್ರು ಏನ್ ಮಾಡ್ತಾರ ಅಂತಂದ್ರೆ ಫಿಶ್ ಬೆಳೆಸ್ತಾರೆ, ರೈಟ್. ಆಮೇಲೆ ಅವ್ರು ತಗೊಂಡೋಗಿ ಸೇಲ್ ಮಾಡ್ತಾರೆ, ರೈಟ್. ಸೊ ನಿಯರ್ ಬೈ ಬಾಗಲಕೋಟೆ ನಾವೇನ್ ಮಾಡ್ತೇವೆ, ಬೆಳಗ್ಗೆ ಕಾಯಿಪಲ್ಲೆ ಬರ್ತದೆ ಇಲ್ಲಿ, ಎಲ್ಲೇ ಒಂದ್ ಕಡೆ ಫೀಲ್ಡ್ ಬೆಳ್ಕೊತಾರೆ, ಇಲ್ಲಿ ಸೇಲ್ ಮಾಡ್ತಾರೆ. ಎಕ್ಸಾಕ್ಟ್ಲಿ ಇನ್ ಸಿಮಿಲರ್ ವೇ ಒರಿಸ್ಸಾದಲ್ಲಿ ಸಿಕ್ಕಾಪಟ್ಟೆ ಮನೆಗೆ ಒಂದೊಂದು ಪಾಯಿಂಟ್ಸ್ ಇದೆ. ಅವ್ರ ಮೇನ್ ಬಿಸ್ನೆಸ್ ಅದೇ. ಅವ್ರು ಏನ್ ಮಾಡ್ತಾರೆ, ಫಿಶ್ ಬೆಳೆಸ್ತಾರ, ಸೇಲ್ ಮಾಡ್ತಾರೆ, ರೈಟ್. ಹಂಗೆ ಯಾವ್ದೋ ಒಂದು ಪಾಂಡ್ ಒಳಗಡೆ ಇವ್ರು ಏನ್ ಹೇಳ್ತಾರ ಅಂತಂದ್ರೆ 1000 ಫಿಶ್ ಬಿಟ್ಬಿಡ್ತಾರ. ಆಫ್ಟರ್ 15 weeks ದೇ ವಿಲ್ ಮೇಜರ್ ದಿ ಪಾಪ್ಯುಲೇಷನ್. 1000 ಇತ್ತು, 15 weeks ಆದ್ಮೇಲೆ ಏನಾದ್ರು ಜಾಸ್ತಿ ಆಗಿದೆ ಹೆಂಗ, ಸೈಜ್ ಜಾಸ್ತಿ ಆಗಿದೆ ಹೆಂಗ, ಅಥವಾ ಪಾಪ್ಯುಲೇಷನ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ ಹೆಂಗ, like that they are going to verify, right? And we want to calculate all these things with the given data. They have given what they have given. They have given. So week 0. How many fishes are there? 1000 fishes. Initially ನಾವೇ 1000 purchase ಮಾಡಿಬಿಟ್ಟು ನಮ್ಮ ಪಾಂಡ್ ಒಳಗಡೆ ಬಿಟ್ಟಿದ್ದೀವಿ. After 15 weeks, what is the catfish population? 1500. After 30 weeks, 3300. So like that they have given. After 120 weeks, what is the population of the fish? 7900. So this is the data available. We have conducted a survey. From the survey, we have obtained this data. Now what I want to do, I want to write an equation for this data. ನಮ್ದು ಮೇನ್ ಏನಂತಂದ್ರೆ ಇದಕ್ಕೆ ನಾವು ಇಕ್ವೇಶನ್ ಬರೀಬೇಕು. ಇಂಜಿನಿಯರಿಂಗ್ ಕೆಲಸ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ ದೇ ವಿಲ್ ಕಂಡಕ್ಟ್ ಆನ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್. ಎಲ್ಲರಿಗೂ ಇಕ್ವೇಶನ್ ಇರಂಗಿಲ್ಲ. ಅವ್ರ ಕೆಲಸ ಏನಪ್ಪಾ ಅಂದ್ರೆ ದೇ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕಂಡಕ್ಟ್ ದಿ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್. ದೇ ವಿಲ್ ಗೆಟ್ ಎ ಡಾಟಾ ಲೈಕ್ ದಿಸ್, and from the data they are going to generate an model. They are going to generate an model means they are going to write down an equation. ಆ equation ಬರ್ಬಿಟ್ಟು ಆಗಲೇ ನಾನು ಹೇಳಿದ್ದಲ್ಲಿ ಏನೋ ಈಗ ಮಗ್ ಜನರೇಟ್ ಮಾಡಿದಲ್ಲ, ಹೆಂಗ ನಾವು ಮಗ್ ಚೇಂಜ್ ಮಾಡೋದು ಹಂಗ. ಒನ್ಸ್ ಯು ಗೆಟ್ ದಿ ಇಕ್ವೇಶನ್, ಸೊ ಯು ಕ್ಯಾನ್ ಮೇಕ್ ಎನಿ ಟೈಪ್ ಆಫ್ ಚೇಂಜಸ್. ಅದರ್ವೈಸ್ ಇಟ್ ಇಸ್ ಡಿಫಿಕಲ್ಟ್, ರೈಟ್? ಓಕೆ, ಇನ್ ದಟ್ ಡೈರೆಕ್ಷನ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕಂಡಕ್ಟ್, or we are going to write down an equation. We are going to develop an equation for this data. Okay. So when we are able to draw the diagram means graph using GeoGebra. I hope you treat it as an x-axis, y-axis. You will get the graph like this. You will get S-type graph. Am I right? Okay. So you will get along with the graph an equation. What is that equation? So this is the equation. What you are observing, f of x is equal to 7924.5403 divided by 1 plus 7.6948 into e to the power minus 0.0523 times of x. That's clear. So this model is called a logistic model, right? This model is called a logistic model. Here, x-axis is treated as weight, y-axis is treated as a population of the catfish. All right. So graph looks like yes. That's clear. Nowadays, all of us are talking about COVID-19, right? ಈಗ ನಮ್ಗೆಲ್ಲ ಹೇಳ್ತಾ ಇದ್ದಾರೆ ಟಿವಿಯಲ್ಲಿ ಜನವರಿ ಒಳಗಡೆ ಇನ್ನೊಂದು ವೇವ್ ಬರ್ತದೆ, ಥರ್ಡ್ ವೇವ್ ಬರ್ತದೆ, ಫೋರ್ತ್ ವೇವ್ ಬರ್ತದೆ. ಹೌ ದೇ ವಿಲ್ ಸೇ ದಟ್ ಇನ್ ದ ಮಂತ್ ಆಫ್ ಜನವರಿ ಥರ್ಡ್ ವೇವ್ ಬರ್ತದೆ ಅಂತ ಅವ್ರಿಗೆ ಯಾರು ಹೇಳಿದ್ರು, ಅಥವಾ ಫೆಬ್ರವರಿ ಒಳಗಡೆ ಬರ್ತದೆ ಅಂತ ಎಲ್ಲರೂ ಹೇಳ್ತಾ ಇದ್ರು. ಹೌ ದೇ ವಿಲ್ ಕಮ್ ಟು ನೋ? They will conduct a survey. On the basis of the survey, they are going to predict, right? So it can be treated as a COVID-19 situation, right? The graph ಏನಿದೆಲ್ಲ ಹಿಂಗೆ ಇರ್ತದೆ. When we observe the second wave ನೋಡಿದ ಮಾತ್ರ ಕೋವಿಡ್ ಹೆಂಗಿತ್ತು, ಅದು ಇನಿಷಿಯಲಿ ಸ್ಲೋ ಇತ್ತು. ಆಮೇಲೆ ಏನಾಯ್ತು, ಸೆಕೆಂಡ್ ವೇವ್ದಾಗ ಸಡನ್ ಆಗಿ ಇನ್ಫೆಕ್ಷನ್ಸ್ ಜಾಸ್ತಿ ಆಯ್ತು. ಆಮೇಲೆ ಏನಾಯ್ತು, ಕಾನ್ಸ್ಟೆಂಟ್ ಆಯ್ತು. So this graph can be compared with the COVID-19 second wave in our country, right? Or you can compare with the first wave. First wave hangatu. Initially it was slow, suddenly it is jumped, then it becomes constant. This is clear, right? And here also, stocking a pond with catfish. Why it is like that, right? Okay, initially ನಾನು ಏನು ಮಾಡಿದೆ, 1000 fish ನನ್ನ ಪಾಂಡ್ ಒಳಗಡೆ ಬಿಟ್ಟೆ. After 120 weeks, right? Totally, how many fishes are there? 7,900. So, 1000 ಅಲ್ಲಿಂದ 7,900 ಆಗಿದೆ. ಆಮೇಲೆ ನಾನೇನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಸಪೋಸ್ ಇಫ್ ಐ ವೇಟ್ ಅನದರ್ 100 ವೀಕ್, ಇದೇನಾಗ್ಬೋದು, ಡಬಲ್ ಆಗ್ಬೋದು, ಇದು ರೇಟ್ ಅಷ್ಟು ಸರಿ ಇಲ್ಲ ಅಂತೇಳಿ ಇನ್ನೊಂದು 100 ವೀಕ್ ವೇಟ್ ಮಾಡಿದೆ ಅಂತಂದ್ರೆ, ಕ್ಯಾನ್ ಯು ಟೆಲ್ ಮಿ, ಕ್ಯಾನ್ ಯು ಥಿಂಕ್ fish population will increase? My answer is no, it will not increase because there is a constraint. There is a constraint. ಏನಿದೆ ಅಂತಂದ್ರೆ ಕೆಲವೊಂದಿಷ್ಟು ಕಂಡೀಷನ್ ಇದೆ. Say for example, in the classroom, how many desks are there? You assume that totally 60 desks are there. Each desk one. In each desk, one student will sit. That's clear. On the desk, because we are going to put some conditions. We have to maintain a social distance, right? So I can accommodate 60 students in a classroom. That is the constraint. That is the condition, right? I cannot accommodate 120 students in a single classroom. Exactly in the similar way, there is a constraint. ಈಗ ಪಾಂಡ್ ಒಳಗಡೆ ಏನಿದೆ ಅಂತಂದ್ರೆ ಅದಕ್ಕೆ ಅದರದೇ ಆದ ರೆಸ್ಟ್ರಿಕ್ಷನ್ ಇದೆ. ನಾ ಎಷ್ಟೋ ಫುಡ್ ಹಾಕಿದ್ರು ಸತಿಗೆ, ಎಷ್ಟೇ ಅದಕ್ಕೆ ನೀರು ಬಿಟ್ಟರು, ಫ್ರೆಶ್ ನೀರು ಬಿಟ್ಟರು ಸತಿಗೆ, ಪಾಪ್ಯುಲೇಷನ್ ವಿಲ್ ಇನ್ಕ್ರೀಸ್ ಅಪ್ ಟು ಸರ್ಟನ್ ಸ್ಟೇಜ್, ಅಂಡ್ ಆಫ್ಟರ್ ದಟ್ ಇಟ್ ಬಿಕಮ್ಸ್ ಎ ಕಾನ್ಸ್ಟಂಟ್. ದಟ್ ಈಸ್ ದಿ ಮೇನ್ ಅಬ್ಸರ್ವೇಷನ್ ಫ್ರಾಮ್ ದಿಸ್ ಗ್ರಾಫ್. Okay. We will come to know all these things. What is the mathematics behind this constraint that should be observed, right? Because we have a model, right? We have a logistic model. What is the mathematics behind it, right? Why it becomes a constant after some time? ಈಗ ಏನ್ ಮಾಡಿದ್ರು ನಾವು 120 ವೀಕ್ಸ್ ಆದ್ಮೇಲೆ 7,900 ಆಯ್ತು. ಅದಾದ್ಮೇಲೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಯಾಕೆ ಆಗ್ಲಿಕ್ಕಿತ್ತು? ಅಥವಾ ಫಿಶ್ ಪಾಪ್ಯುಲೇಷನ್ ಇಟ್ ಮೇ ಡಿಕ್ರೀಸಸ್. ಬಹಳ ಪಾಪ್ಯುಲೇಷನ್ ಜಾಸ್ತಿ ಆದ್ಮೇಲೆ ಯಾವ್ದೋ ಡಿಸೀಸ್ ಬಂದು ಒಂದೊಂದು ಫಿಶಸ್ ಸತ್ತು ಹೋಗ್ಬಿಡ್ಬೋದು. ಅವಾಗ ಏನಾಗ್ಬೋದು, ಅದು ಪಾಪ್ಯುಲೇಷನ್ ಡಿಕ್ರೀಸು ಆಗಬಹುದು. ದಟ್ಸ್ ವೈ ಯು ಕ್ಯಾನ್ ಸಿ ದಿಸ್ ಪಾಯಿಂಟ್ ಈಸ್ ಬಿಲೋ ದ ಲೈನ್. ಇಲ್ಲೇನಿದೆ, ಪಾಪ್ಯುಲೇಷನ್ ಕಡಿಮೆ ಆಗಿದೆ. ಅರೌಂಡ್ 80th ವೀಕ್, 80th ಮತ್ತು 100th ವೀಕ್ ನೋಡಿದ್ರೆ ಸೊ ಫಿಶ್ ಪಾಪ್ಯುಲೇಷನ್ ಏನಾಗಿದೆ, ಇಲ್ಲಿ ಕಡಿಮೆ ಆಗಿದೆ. ಆಮೇಲೆ ಮತ್ತೆ ಜಾಸ್ತಿ ಆಗಿದೆ. ನೆಕ್ಸ್ಟ್ ಇಟ್ ಮೇ ರಿಮೇನ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್, ರೈಟ್? ಸೊ ಇದ್ರ ಹಿಂದ್ಗಡೆ ಏನಿರ್ತದೆ ಅಂದ್ರೆ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಇರ್ತದೆ. What is the mathematics? As I mentioned, it is a logistic model. Here, as t increases, e to the power minus b into t, it becomes 0, tends to 0. It becomes 0 means this may tends to 0 as t increases. Ille t anadalla increase akanta hodanga, right? And the number of weeks enidella ಇದು ಇನ್ಕ್ರೀಸ್ ಆಕ್ಯಂತ ಹೋದಾಗ e to the power minus b into t ಏನಾಗ್ತದೆ ಅಂತಂದ್ರೆ it tends to 0. So because of this condition, it remains constant. Am I right? I hope it is clear. So this graph can be applied to many fields, not necessarily for the catfish. I hope it is clear. Okay. Now I want to take another problem. Suppose if we want to study a world population, right? I will give the data. The following table gives the population of the world in the 20th century. What I want to do, I want to draw a scatter plot, and note that a linear model is not appropriate. It means we will not get a linear model. Linear model means y is equal to mx plus c. I hope you are already familiar with y is equal to mx plus c. Find an exponential function that models population growth. Draw a graph of the function that you found together with the scatter plot. How well does the model fit the data? Use the model that you found to predict world population in the year 2020. Right? Okay, they have given the data. It is available in the internet. In the year 1900, what was the population? 1,650 millions. That's okay. Next, 1910, 1750. 1960, 3020, all right? So next in 2000, 6060 millions, like that they have given the data. I want to generate the equation. I want to develop an equation. How I am going to develop an equation? Using the tool, namely GeoGebra, right? So you can type the Excel sheet. I hope we'll get the graph automatically. This is clear. So you can observe the data. So what will come to know? In the year 1930, so there is a small decrease in the population, right? Small decrease in the population. You can find out what is the reason why the population is decreasing around 1930 or around 1940. Is it clear? Around 1950. Is it clear? So when we go through the literature, we will come to know. So there may be a war. There may be a first and second world war during that period. So that's why the population is decreasing. Again, it is increasing. Is it clear? Again, it is increasing. Now you can observe in the year 2000, so it is around 6.1, approximately 6.1 million. Is it clear? Right? Okay. Suppose exactly in the same rate, population is increases. It is around 20 years back data. Right? Now you can see what may be the population at 2020. Is it clear? At 2021. So you can calculate. How we are going to calculate? You want to write down an equation. You'll get an exponential equation. Replace a variable by 2020. I hope we'll get. I think you may get. I have not calculated it. You may get 7.1 billion. When you go through the Google, will come to know 7.1 billions population. Right? So suppose if the population is increases in the same rate, what will happen? What will happen means, so we will not get the space in the earth surface, right? Because that is the constraint. So that is the constraint. So in the year 2801, the year 2801, so every person may get 4 square meter, right? In the year 201, remember, in the year 2801, so every person will get 4 square meter. Even we can't build a house. We call it as an every person will get a standing room, right? Per square meter. That's clear. So that can be predicted with the help of this data, right? Okay. I have taken some problems and I have solved all these problems using the GeoGebra. Now you will come to know the importance of GeoGebra. So why we want to study GeoGebra, right? So it doesn't mean that is it not possible to solve all these problems without GeoGebra? Answer is no. So we can solve these problems without GeoGebra. But sometimes what will happen? No. So we'll conduct the experiment and sometimes it is difficult to find out the analytical method. So in that case, we need the help of tools like GeoGebra. Or sometimes if you want to explore a particular problem, in that case also we need the help of tools like GeoGebra. In such a situation, we are going to use GeoGebra. It doesn't mean that we can do each and everything from the tool only. No, there is no such type of answers, right? ಎಲ್ಲಾನು ಜಿಯೋಜಿಬ್ರಾದಿಂದನೇ ಮಾಡ್ತೀನಿ ಅಂತಲ್ಲ, ಎಲ್ಲಾನು ಟೂಲ್ ಇಂದನೇ ಐ ವಿಲ್ ಫೈಂಡ್ ಔಟ್ ಅಂತ ಅಲ್ಲ. So you can use in a limited way. It has its own limits. So in that direction, so if you use GeoGebra, it helps us to explore the mathematics. It's my suggestion, right? Okay. So now you are observing a photograph, right, of Ramanujan. So what I will come to know, or what we will come to know from this picture, right? So there is a quotation. What is that quotation? A picture says more than 1,000 words. Now, in the next 15 to 20 minutes, I will give what is GeoGebra, how we are going to use GeoGebra. That's clear, right? So one picture says more than 1,000 words. It represents 1,000 words. A dynamical animation says more than 1,000 pictures. That's clear, right? So you may ask, who is the creator of GeoGebra, right? GeoGebra create ಮಾಡಿದವರು ಯಾರು ಅಂತ ನೀವು ಕೇಳಬಹುದು. ಇಲ್ಲಿ ನೋಡ್ತಾ ಇದ್ದೀರಿ ಪಿಕ್ಚರ್ ನಲ್ಲಿ ಇವರೇ ಕ್ರಿಯೇಟ್ ಮಾಡಿದ್ರು, ರೈಟ್? ಮಾರ್ಕಸ್ ಮಾನೆನ್ ವಾಟರ್ ಅಂತೇಳಿ, ರೈಟ್? ಸೊ ಹಿ ಇಸ್ ದಿ ಕ್ರಿಯೇಟರ್ ಆಫ್ GeoGebra. So GeoGebra developed for mathematics. He is not a mathematician. So he is a computer science guy, right? So created GeoGebra. So why he created GeoGebra? There is a small story behind this, right? Once ಏನ್ ಮಾಡ್ತಾ ಇದ್ರು ಕಂಪ್ಯೂಟರ್ ಸೈನ್ಸ್, ಸೊ ಥೀಸಿಸ್ ಸಬ್ಮಿಟ್ ಮಾಡ್ಬೇಕಾಗಿತ್ತು, ಅಲ್ಲಿ ಇಕ್ವೇಶನ್ ಏನ್ ಮಾಡ್ತಾ ಇದ್ರು, ಪ್ರಾಬ್ಲಮ್ ಕೊಡ್ತಾ ಇತ್ತಂತೆ. ಅದಕ್ಕೋಸ್ಕರ ಸೊ ಈಸ್ ಕಂಪ್ಯೂಟರ್ ಸೈನ್ಸ್ ಆಗಿರೋದ್ರಿಂದ ಅವ್ರು ಏನ್ ಮಾಡಿದ್ರು, ಪ್ರೋಗ್ರಾಮ್ ಬರ್ಕೊಂಡು ಥೀಸಿಸ್ ಸಬ್ಮಿಟ್ ಮಾಡಿದ್ರು, ಫ್ರೆಂಡ್ಸ್ಗೆ ತೋರಿಸಿದ್ರು, ಅದೆಲ್ಲ ಚೆನ್ನಾಗಿ ಐತೆ ಅಂತ ಹೇಳಿದ್ರು. ಮುಂದೆ ಅವ್ರು ಏನ್ ಮಾಡಿದ್ರು, ಇಡೀ ವರ್ಲ್ಡ್ಗೆ ಗಿಫ್ಟ್ ಅಂತ ಕೊಟ್ಬಿಟ್ರು. ಅಸಲೇ ಇಟ್ ಇಸ್ ಆನ್ ಓಪನ್ ಸೋರ್ಸ್ ಸಾಫ್ಟ್ವೇರ್, right? It is an open source software that everybody can use freely, right? So nowadays, all over the world, around 190 plus countries are using GeoGebra, right? So why it is called GeoGebra? So it is a combination of geometry and algebra. It is a combination of geometry and algebra. Or ಏನ್ ಮಾಡಿದ್ರು ಅಂದ್ರೆ geometry ಒಳಗಡೆ 3 ಕ್ಯಾರೆಕ್ಟರ್ ತಗೊಂಡ್ರು. ಯಾವ್ಯಾವ ಕ್ಯಾರೆಕ್ಟರ್? GEO. ಆಲ್ಜಿಬ್ರಾ ಒಳಗಡೆ ಏನ್ ಮಾಡಿದ್ರು ಅಂತಂದ್ರೆ GEBRA ತಗೊಂಡ್ರು. ಸೊ ಜಾಮೆಟ್ರಿ ಒಳಗಡೆ ಫಸ್ಟ್ 3 ಕ್ಯಾರೆಕ್ಟರ್ಸ್, ಆಲ್ಜಿಬ್ರಾ ಒಳಗಡೆ ಲಾಸ್ಟ್ 5 ಕ್ಯಾರೆಕ್ಟರ್ಸ್ GEBRA. ಅವನ್ನೆರಡು ಕೂಡಿಸಿ ಒಂದು ವರ್ಡ್ ಕ್ರಿಯೇಟ್ ಮಾಡ್ತಾರೆ, ಹೊಸ ವರ್ಡ್. ವಾಟ್ ಇಸ್ ದಟ್ ವರ್ಡ್? GeoGebra. Is it clear? Right? So as I mentioned, GeoGebra is a tool that will graphically demonstrate and help teach the concepts of geometry and algebra. So it will provide connections between them. ಆಗಲೇ ಹೇಳಿದೆ, ಕೆಲವೊಂದಿಷ್ಟು ಬೋರ್ಡ್ ಮೇಲೆ ತೋರಿಸಲಿಕ್ಕೆ ಆಗಂಗಿಲ್ಲ. ಸೊ ಅಂತಂದ್ರೆ ನಾವ್ ಏನ್ ಮಾಡೋದು, ವಿ ಕ್ಯಾನ್ ಯೂಸ್ ದಿ ಹೆಲ್ಪ್ ಆಫ್ ಆರ್ ವಿ ಕ್ಯಾನ್ ಟೇಕ್ ದಿ ಹೆಲ್ಪ್ ಆಫ್ ದಿಸ್ ಟೂಲ್, ಅಂಡ್ ಇಟ್ ಈಸ್ ಈಸಿ ಟು ಲರ್ನ್ ಅಂಡ್ ಯೂಸ್, ರೈಟ್? ಸೊ ಇಫ್ ಯು ಕ್ಯಾನ್ ಡೌನ್ಲೋಡ್. ಮೊಬೈಲ್ ವರ್ಷನ್ ಇದೆ, ಲ್ಯಾಪ್ಟಾಪ್ ವರ್ಷನ್ ಇದೆ, ನೀವು ಯಾವ್ದಕ್ಕೆ ಬೇಕಾಗಲ್ಲ ಆ ವರ್ಷನ್ ಇದೆ, ರೈಟ್? Just by visiting this site www.geogebra.org, very easily it can be downloaded, right? So GeoGebra is a dynamic geometry system. So you can do all these things. You can create a points, vectors, segments, lines, conic sections, whatever you want, functions, etc. You can do all these things. So you can define variables, numbers, derivatives, right? As I have shown earlier. So this is graphic window, algebraic window. All these are the tools, right? So these are the advantages and limitations, right? What are the limitations? Decide at what level the use of mobiles for computers should be taught. ನನ್ನ ಕಡೆ ಮೊಬೈಲ್ ಇದೆ ಅಂದ್ರೆ I cannot do each and everything from the mobile. ಹಂಗೆ GeoGebra ಇದೆ ಅಂತೇಳಿ ಇದರಿಂದ ನಾನು ಎಲ್ಲಾನು ಮಾಡ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ, ನನಗೆ ಗೊತ್ತಿರಬೇಕು ಲಿಮಿಟೇಷನ್ಸ್, ರೈಟ್? ಓಕೆ, ಸೊ ಯು ಕ್ಯಾನ್ ಯೂಸ್ ಆಲ್ ದೀಸ್ ಟೂಲ್ಸ್. ಸೊ ಯು ಕ್ಯಾನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಆಂಗಲ್ಸ್. in more angle ಬೇಕಾಗಿತ್ತು simply in input bar you can type alpha beta gamma ಅಂದ್ರೆ, so it will give the angles. So for example, if you want to calculate polynomial x minus 3 to the power 2 ಅಂತಂದ್ರೆ it will give the expansion along with the graph. That is the advantage. ಈಗ ಒಂದೇನೋ equation ಇದೆ, ಅದರ ಗ್ರಾಫ್ ಏನ್ ಬರ್ತದೆ ಅಂತ ನನಗೆ ಗೊತ್ತಿಲ್ಲ, shape of the graph I don't know. What I will do, it is very simple. I will take a mobile, then have an GeoGebra tool or GeoGebra app, and I will type that equation, immediately I will get the graph. Is it clear? Right? So suppose if you type like this, simplify sin x by cos x, it will give the simplification version along with the graph. That is the advantage of GeoGebra. You can give any such type of commands, right? So you can type a function like this, x into x minus 1 to the power 2 by 3 with range. ಈಗ ನನಗೆ ಏನ್ ಮಾಡಬೇಕು, ಗ್ರಾಫ್ ಹಾಕಬೇಕು, -2 to +2. Yes, it is possible. You can draw the graph within a range. Range ಕೊಡ್ಬೋದು, ಆ ರೇಂಜ್ ಕೊಟ್ಟರೆ ಅದರಲ್ಲಿ ಏನ್ ಮಾಡ್ತದೆ ಗ್ರಾಫ್, ರೈಟ್? Then I can define my own functions, user defined functions. So in mathematics we will write like this: f of x is equal to 0 when x is less than 0, f of x is equal to 3 when x is greater than or equal to 0. So how I am going to write down this function in GeoGebra? ಇಲ್ಲೇನು ಕೆಂಪು ಅಕ್ಷರ ಬರ್ದಿದ್ದಾವಲ್ಲ, ಈ ತರ ಡಿಫೈನ್ ಮಾಡಿ. f of x is equal to, if x is less than 0, you can give the range 0 to 3. I hope we'll get the graph of this function, right? So similarly, f of x is equal to minus x, x is less than 0, f of x is equal to x, x is greater than or equal to 0. So this can be written in GeoGebra in this form. ಈ ತರ ನಾವೇನ್ ಮಾಡ್ಬೋದ್ರಿ, ಬರೀಬಹುದು, right? So similarly, you can write down a function like this. in GeoGebra. All these things are available in the tool. Help box, you will get all these things. Suppose if you want to construct a function above x equal to sin x, sin 2x, sin 3x. So you can write down in this form. I hope we'll get right along with the graph. I can draw the graph between 0 to pi, pi to 2 pi, right? Suppose if you want to highlight this graph, yes, it is possible to highlight. So you can highlight the particular part, right? So like this. So sin x with red color, sin 3x with a different color, right? Above 3x with another color. So how I am going to highlight? So using this command. So highlight ಮಾಡಬಹುದು. Suppose you can type an equation, x square plus y square is equal to 4. In GeoGebra, if you type this equation, no, I hope we'll get a graph of this equation. Not necessarily this equation. You can type any equation. You have the equation. I think I have seen in your syllabus, you are going to learn polar coordinates, right? So if you want, you can verify polar coordinates. Means you can draw polar coordinates in GeoGebra. So for example, a radar detects two aeroplanes at the same altitude. Their polar coordinates are, they have given 8 mile, 110 degree, and 5 mile, 15 degree. Calculate how far apart are the airplanes. Now, imagine that you are the supervisor of the airport, right? Two flights coming towards the airport. Now you want to find out the distance between the two airplanes. How you are going to calculate, right? So we need a simple formula for this. So it can be solved. So using GeoGebra, this problem can be solved. Radar detectors ಒಳಗಡೆ ನಾವು ಏನು ಮಾಡೋದು, ಎರಡು ಪ್ಲೇನ್ ನಮ್ಮ ಏರ್ಪೋರ್ಟ್ ಕಡೆ ಬರ್ತಾ ಇದ್ದಾವೆ. ಅದು ನಾನು ಏನು ಮಾಡಬೇಕಾಗಿದೆ, ಒಂದು ಮೊದಲು ಇಳಿಸಬೇಕು, ಆಮೇಲೆ ಇನ್ನೊಂದಕ್ಕೆ ಸಿಗ್ನಲ್ ಕೊಡಬೇಕು. ಅದಕ್ಕೋಸ್ಕರ ವಾಟ್ ಐ ವಿಲ್ ಡೂ, ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಟೂ ಏರೋಪ್ಲೇನ್ಸ್, ಏರೋಪ್ಲೇನ್ ಎ, ಏರೋಪ್ಲೇನ್ ಬಿ. ಅವ್ರು ಆಂಗಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಒಂದು 15 ಡಿಗ್ರಿ, ಇನ್ನೊಂದು 95 ಡಿಗ್ರಿ ಬರ್ತದೆ. So I am going to calculate the distance between A and B. It is very simple, 9.8, right? So how I am going to calculate ಅಂತಂದ್ರೆ, I hope I have studied sine and cosine rule, right? Sine and cosine rule ಅಂತ ನೀವು ಹೈಸ್ಕೂಲ್ ನಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡಿರ್ತೀರಿ. ಅದನ್ನ ಯೂಸ್ ಮಾಡಿಬಿಟ್ಟು ನಾವು ಏನು ಮಾಡೋದು, we are going to calculate the distance between two aeroplanes, right? Here what we will come to know that you are going to study polar coordinates, no? So how I am going to draw 8, 110 degree or 5, 15 degree. ಇದನ್ನ ಹೆಂಗೆ ಡಿಫೈನ್ ಮಾಡಬಹುದು? How I am going to draw a point. Another point is 3, 45, 3, 225, and more graphs. Is it clear? So it is very simple. You are going to draw this type of polar coordinates in GeoGebra, right? You can draw a point like this. So here I have created n. You can create a few more points. What are some points in here? Create model, right? Yes. Right. Now you are observing, I have created infinitely many points with the animation. Right. So first I have created 1 or 2 points. Now I will make it as an animation. So you are going to create a point. So it is very, very important. I cannot show this on the blackboard. Blackboard ಮೇಲೆ ಇದನ್ನು ತೋರಿಸಲಿಕ್ಕೆ ಬರೋದಿಲ್ಲ. ಇಲ್ಲಿ ಇನ್ನೊಂದು ಏನಪ್ಪಾ ಇಂಪಾರ್ಟೆಂಟ್ ಅಂತಂದ್ರೆ, one point can be defined infinitely many ways. Polar coordinates, same point can be represented infinitely many ways. Define a polar point 1, 315, polar point 1, -45. 1, 675. Now I will ask, what is your conclusion? All the three are same or different, right? You ಮೂರು ಏನಾಗ್ತಾವ ಅಂತಂದ್ರೆ same. It means same polar point can be represented with different. ಎಲ್ಲ ಏನಾಗ್ತದೆ, it represents only one point. Basically, that's why I have written here all represents the same point. Namely, P is equal to P1 is equal to P2. So that is the advantage of GeoGebra. ರೈಟ್. ನಾವು ಗ್ರಾಫ್ ಇದು ಬೋರ್ಡ್ ಮೇಲೆ ಹೇಳ್ತೀವಿ ಏನಂತ ಹೇಳಿ, ಇವೆಲ್ಲ ಮೂರು ಒಂದೇ ಪಾಯಿಂಟ್ ರೈಟ್. ಸೊ ಅದನ್ನ ಏನ್ ಮಾಡ್ಬೋದು, ಡ್ರಾ ಮಾಡಿ ನೋಡ್ಬೋದು. ಇಫ್ ಯು ಹ್ಯಾವ್ ಎ ಟೂಲ್ ಲೈಕ್ GeoGebra, right? So you can create a arbitrary polar point. Arbitrary polar point ನಾನು ಏನ್ ಮಾಡ್ಬೋದು, ಸೊ ಕ್ರಿಯೇಟ್ ಮಾಡ್ಬೋದು. Right? So you can create like this. ಎಲ್ಲಿ ಬೇಕಲ್ಲ ಅಲ್ಲ ನಾವು ಏನ್ ಮಾಡ್ಬೋದು, ಕ್ರಿಯೇಟ್ ಮಾಡ್ಬೋದು. ಐ ಕ್ಯಾನ್ ರೊಟೇಟ್ ಅರೌಂಡ್ ದಿ ಸರ್ಕಲ್ ಆರ್ ಕ್ಲಾಕ್ ವೈಸ್ ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್. ನನಗೆ ಹೆಂಗ್ ಬೇಕಂದ್ರೆ ನಾನು ಏನ್ ಮಾಡೋದು, ಐ ಆಮ್ ಏಬಲ್ ಟು ಕ್ರಿಯೇಟ್ ಎ ಪಾಯಿಂಟ್. ಎಲ್ಲಿ ಬರ್ತದಲ್ಲ, ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಫೈಂಡ್ ಔಟ್ ದಿ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಆರ್ ಅಂಡ್ ಥೀಟಾ. ಸೊ ಹೌ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ರಿಪ್ರೆಸೆಂಟ್ ಪೋಲಾರ್ ಕೋಆರ್ಡಿನೇಟ್ಸ್ ಆರ್ ಅಂಡ್ ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ಆರ್ ಅಂಡ್ ಥೀಟಾ. Is it clear? Right? Okay. So define a polar point 2, 5/6 minus 2. Sometimes confusion ಆಗುತ್ತೆ ಇಲ್ಲಿ. R because R represents the distance. ಇಲ್ಲ ನಾನು ನೆಗೆಟಿವ್ ಬರ್ತೀನಿ. Polar coordinates ಒಳಗಡೆ R ನೆಗೆಟಿವ್ ಬರ್ತೋ ಇಲ್ಲ. Sometimes it is possible to write down in negative form also. ಬರಿಬಹುದು. So -2, 7/6 ಇವೆಲ್ಲಾನು ಏನ್ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾವ ಅಂತಂದ್ರೆ ಒಂದೇ ಪಾಯಿಂಟ್ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತದೆ. The polar point 2, 5/6 has infinitely many polar coordinate pairs. ಈಗ ಅದನ್ನು ತೋರಿಸಿದ ಸರ್ಕಲ್ ಏನ್ ಜನರೇಟ್ ಆಗಲ್ಲ ಅಲ್ಲಿ, ರೈಟ್. ಸೊ ಇಫ್ ಯು ಆಸ್ಕ್ ಟು ರೈಟ್ ದಿ ಗ್ರಾಫ್ R is less than 0, R is less than 0 ಬರೀಬಹುದು, ರೈಟ್. ಅದು ಗ್ರಾಫ್ ಏನ್ ಮಾಡಬಹುದು, ಕ್ರಿಯೇಟ್ ಮಾಡಬಹುದು. You will get the circle with radius 3, right? Suppose if I want to draw the graph of R is equal to 3 times of sin x, ಏನು ಬರ್ತದೆ ಇದು ನೋಡ್ಬೇಕಂತ ನನಗೆ ಗೊತ್ತಾಗಲ್ಲ. ಅದಕ್ಕೆ ನಾನು ಏನು ಮಾಡಬೇಕು, I want to use the tool GeoGebra. I hope you'll get the circle, right? So R is equal to 3 times of sin x means you'll get a circle. So like that you can draw the graph of any equation, any function. R is equal to 3 cos x, R is equal to 3 secant x. I hope you'll get a straight line. ಇದ್ರ ಗ್ರಾಫ್ ಹಾಕಿದ್ರೆ ಅಂದ್ರೆ ನಮ್ಗೆ ಏನ್ ಬರ್ತದೆ, ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಬರ್ತದೆ. ಸೊ ಹೌ ವಿಲ್ ಗೆಟ್ ಸ್ಟ್ರೇಟ್ ಲೈನ್? ಎಸ್, ಇಲ್ಲಿ ಏನಾಗ್ತದೆ ಅಂದ್ರೆ ವಿಲ್ ಗೆಟ್ ಎ ಸ್ಟ್ರೇಟ್ ಲೈನ್. ಇಲ್ಲಿ ಏನ್ ಮಾಡಬಹುದು, ಫ್ರಮ್ ದಿ ಪೋಲ್, ದಿಸ್ ಇಸ್ ದಿ ಪೋಲ್, ಯು ಕ್ಯಾನ್ ಡ್ರಾ ಎ ಲೈನ್ ಆರ್. ಯು ಕ್ಯಾನ್ ಡ್ರಾ ಎ ಲೈನ್ ಆರ್. ಆಸ್ ಥೀಟಾ ಇನ್ಕ್ರೀಸಸ್, ಆರ್ is also increases. That idea will come to know from this diagram. As theta increases, R is also increases. That is the conclusion, right? So like that you can draw the diagram of 1 plus 2 cos x, 1 plus 2 sin x, right? 1 plus sin x, 1 minus sin x, right? So in general, t plus k sin x. You can draw the graph of t plus k sin x, right? Okay. So now you are observing the graph of d plus k or d minus k sin x. So you can change the value of d, right? So it becomes a circle. It becomes a circle. Otherwise, it is changing. So we cannot do these things on the board. Board value like a circle. That is the advantage of the technology. You can take the advantage of the technology, right? Yes. So this is the beauty of a GeoGebra. D minus k into sin x or d plus k into sin x, right? So now you want to convert Cartesian to polar form. It is possible to convert Cartesian into polar form. How we are going to convert Cartesian to polar form? So for example, we have an equation y is equal to 2x square, right? So y is equal to 2x square. When you draw the diagram of y is equal to 2x square, you will get a curve like this. You will get a parabolic curve, right? So using an equations, I am going to convert into polar form, right? So what is the polar form? So if I convert y is equal to 2x square, I will get sin theta by 2 times of cos square theta, right? So these two are equal. So I have drawn a curve in polar form. Now you are observing two graphs. So it is possible to create two graphs in the GeoGebra. Is it clear? So this is algebraic window, graph 1 window, graph two window. First one is Cartesian form. Second graph is polar form. This is the graph of sin theta by 2 cos square theta. And this is the graph of y is equal to 2x square. Right? ಎರಡು graph same ಇದೆ. Is it clear? Right? So it means 2x square is equal to sin theta by 2 times of cos square theta. Right? ಇಲ್ಲಿ ನಾ ಏನ್ ಮಾಡಬಹುದು ಅಂತಂದ್ರೆ ಓಕೆ ಐ ಹ್ಯಾವ್ ಡ್ರಾನ್ ವೈ ಯು ವಾಂಟ್ ಟು ಡ್ರಾ ಎ ಕರ್ವ್ ಇಲ್ಲಿ ನೋಡ್ರಿ ಇಲ್ಲಿ ಏನಾಗ್ತದೆ ಅಂತಂದ್ರೆ ಆಸ್ ಆರ್ ವ್ಯಾಲ್ಯೂ ಇನ್ಕ್ರೀಸಸ್ ಆರ್ ಮೇಲ್ಗಡೆ ಹೋದಂಗೆ ಇದ್ರದ್ದು ವಿಡ್ತ್ ಏನಿದೆಯಲ್ಲ ಕರ್ವ್ದು ವಿಡ್ತ್ ಈಸ್ ಗೋಸ್ ಆನ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ವೈ ಇಟ್ ಈಸ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ಅಂತ ನೀವು ಕೇಳ್ಬೋದು ಇಲ್ಲಿ ಆದ್ರೂ ಅಷ್ಟೇ ಆಸ್ we move upward higher values ಹೋದಂಗೆ width of the curve is goes on increasing. That depends upon x. The Cartesian form ಒಳಗಡೆ as x increases ಅಲ್ಲ ಹಂಗೆ x increase ಆದಾಗ width of the curve is also increases. Right? How do you say in case of polar form? As theta increases, so width of the curve is also increases. ಈ theta value increase ಆದಾಗ ನಿಮ್ಗೆ ಏನಾಗ್ತದೆ increase ಆಗ್ತದೆ. Right? So sometimes it becomes an infinity by calculating. So now ಏನು ಮಾಡಬಹುದು theta is equal to values ಆಗ್ತಾವ 90 degree ಆದಾಗ ಇದು infinity ಆಗಿರ್ತದೆ. Right? So 89 ಹಾಕಿದಾಗ you will get a large number. That should be there in our mind. So we can conclude these things from the conversion Cartesian to polar. All right? Okay. Cartesian to polar. It is one more similar type of example. That's why I'm going to skip Cartesian to polar form. Right? So Cartesian to similar type of examples. X minus 2 square plus y square is equal to 4. So it is an Cartesian form. I hope we'll get an circle. ಅದು Cartesian form ಇದ್ದಾಗ ಏನು ಬರ್ತದೆ circle ಬರ್ತದೆ. Right? So now I am going to convert x minus 2 whole square plus y square is equal to 4 to polar form. ನಿಮ್ಮ syllabus ಅಲ್ಲಿ ಇದೆ. I think if I convert this equation into polar form, I will get 4 times of cos theta, and I will draw the diagram of 4 cos theta. What is the diagram of 4 cos theta? Is also a circle, right? So I hope you are observing both the graphs, both are same. Right? Okay. So next you can find out the derivative also, derivative of any function. So if you type this command derivative of x square, right? So you will get the graph of x square. Sorry, the derivative of x square. Derivative of x square is 2x. You will get the graph of 2x, right? So derivative of sin x. This command I type ಮಾಡಬಹುದು. Derivative of sin x is cos x. I will get the graph of cos x. Similarly, you can type derivative of any function. You will get function along with the graph. Suppose if you want to calculate nth derivative. Is it possible? Yes, it is possible. When say for example, I am able to calculate fifth derivative, right? For the function. For the type ಮಾಡಬೇಕಂತಂದ್ರೆ derivative function comma you can type n or in general function comma n to get the nth derivative, right? I hope you are observing this slide. Just to observe what you mean by derivative. What is the geometrical meaning of derivative? All of us know that the geometrical meaning of derivative is the slope of the tangent. All right? Slope of the tangent. Now you are observing it. Tangent is moving along the curve. Is it clear? Tangent is moving along the curve with different colors. Tangent the color ಏನಾಗ್ತಾ ಇದೆ ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆ. ಒಮ್ಮೆ ಗ್ರೀನ್ ಆಗ್ತದೆ. Next red black. Right? So why it is? So you can say that derivative is positive ಇರಬಹುದು, negative ಇರಬಹುದು ಅಥವಾ zero ಇರಬಹುದು, right? ಈಗ ನೋಡಿ ಗ್ರಾಫ್ ಮೇಲ್ಗಡೆ ಹೋಗುವಂತಾಗ ಗ್ರೀನ್ ಇರ್ತದೆ ಅಂದ್ರೆ it is understood that derivative is positive, right? Horizontal to parallel to x axis ಇದ್ದಾಗ black ಆಗ್ತದೆ, parallel to x axis ಇದ್ದಾಗ black ಆಗ್ತದೆ. It is understood that derivative is zero. ಅದು ಗ್ರಾಫ್ ಕೆಳಗಡೆ ಬರುವಂತಾಗ ರೆಡ್ ಆಗ್ತದೆ. Is it clear? Negative. So that is the indication. So we can do all these things with the help of GeoGebra. Right? So if you want, you can construct a derivative. So construction of derivative can be done by typing these 4 statements. ಇದನ್ನೇ ನೀವು ಟೈಪ್ ಮಾಡಿದ್ರೆ ನೀವು ಏನು ಮಾಡೋದು construction ಮಾಡಬಹುದು. I will show you how we are going to construct. I will not type all those statements. I have already typed. I have already constructed. So you can take a curve and you can take a point on the curve, draw the tangent. Then I'm going to move the tangent along the curve. Yes. So now it is generated. The red line in generate. I will show you once again. Yes. So it is generating a straight line. All right. Okay. So this is the derivative of the given function. Here, what is the given function? Now you can observe in the algebraic method. The given function is x square plus 2x plus 1. So if I differentiate x square, I will get 2x. If I differentiate second term 2x, I will get 2. So it means if I differentiate the given function, I will get 2x plus 2. 2x plus 2. So it means it represents a straight line. This is very famous. Like that, you can construct. Right? You can type these commands for the construction of derivative. Right? So exactly in the similar way, you are going to construct a partial derivative. Then in a time being skip when you are moving into higher semester, means higher education, engineering join other partial derivatives. So it can be constructed. So time being, I'm not going to discuss about the partial derivative. I'm going to skip this one. Continue ಮಾಡಬಹುದು ಸರ್. ಇನ್ನೊಂದು ವೆಬ್ಸೈಟ್ ಕೆಲಸ ಡೆಸ್ಕ್ಟಾಪ್ ಮೇಲೆ ಇದೆ ಅಂತ ಕ್ಲೋಸ್ ಮಾಡಿ ಸರ್. ಇನ್ನೊಂದು 15 ನಿಮಿಷ ಕಂಟಿನ್ಯೂ ಮಾಡ್ಬೋದು ಸರ್. ತೋರಿಸ್ಬಿಡ್ತೀನಿ ಸರ್ ಸ್ಲೈಡ್ಸ್ ನಾವು Okay. So whenever you want to approximate a particular function, how we are going to approximate a function. So this is also an important concept in engineering. So for example, I am going to use Taylor series. Yes. So by using the Taylor series, we are going to approximate the function, right? I am unable to show you that GeoGebra 5. So visualization plays an important role. So as we have mentioned, we are able to calculate slope dy by dx equal to 0.2. X into y is a differential equation. We can use some values for x and y. So by giving some values for x and y, we are able to calculate slope, right? So I have taken these two diagrams from the textbook, right? You can draw the tangent at this point, right? So now, with the help of all these slopes, it is possible to construct a slope field. Means, using that they have given a differential equation, you want to find out the solution of a differential equation. So without calculating the solution of a differential equation, you can predict the solution of a differential equation. On the differential equation, adana solve madladane now ಏನು ಮಾಡಬಹುದು, you can predict the solution. Then you may ask, how it is possible? Without solving the differential equation, how we are going to predict the solution? With the help of a slope field. Slope field and small slopes on the range that -2 to +2, -3 to +2, right? So it represents a particular pattern. From this pattern, I will come to know the solution of the given differential equation. ಈಗ ಇಲ್ಲಿ ನೋಡಿದ್ರೆ ನನಗೆ ಒಂದು ಪ್ಯಾಟರ್ನ್ ಕಾಣಿಸ್ತಾ ಇದೆ, ರೈಟ್? ಅದೇನು ಪ್ಯಾಟರ್ನ್ ಅಂತ ನಿಮಗೆ ತೋರಿಸ್ತೀನಿ. Unable to open this file, right? So how we are going to calculate slope field, right? Slope is 0 means I hope you'll get a line like this, right? Slope 1 means you'll get a line like this. Slope 2 means just this slope, Slope is increasing. Sometimes slope may be in terms of -1, -2. So you'll get a line like this, I have created manually. All lines are approximately now create material, right? Approximately, we can represent slope of these numbers in this form. ಈ ಸ್ಲೋಪ್ 1 ಅಂದ್ರೆ ಅದರ ಗ್ರಾಫ್ ಹೆಂಗ್ ಬರ್ತದೆ ಹಿಂಗ್ ಬರ್ತದೆ. If I say that slope is 4, I hope you'll get a graph like this. If I say that slope is -4, you'll get a graph like this. So by using all these linear lines, it is possible to construct slope field, right? They have given a differential equation dy by x equal to x plus 5. So I am going to construct slope field. How I am going to construct it? I will take x is equal to some value, y is equal to some value. So for example here, in this example, I want to take x is equal to -3, y is equal to 2. What is the slope? X plus y again, -3 plus 2 means you will get -1. So you are able to write down the slope like this. So like that you are able to write down the slope like this. Now I am going to change the x and y value. You will get a corresponding slope. You will get a corresponding slope. You will get a corresponding slope. Right? Okay. So this you may call it as a slope field. From this slope field, it is possible to predict solution of the given differential equation. That is the idea. Right? Okay. This is the slope field. This is the slope field. I have created it. Just go through. Take any equation. You can draw the slope field. How you are going to draw the slope field? It is very simple in GeoGebra. In the input, if you write slope field and a differential equation, you will get the slope field of the differential equation. And you can find out the solution. You can compare with the prediction. So red line in front of this is the solution I have obtained. And I have drawn the diagram. And I am comparing with the slope field. With another almost all coincidence. So that's fine. So my prediction is correct. Is it clear? Okay. So you can find out the family of curves. So we have an equation. It is possible to find out a family of curve. Right? Family of curve. Is it clear? Okay. They will give a differential equation with y of 0 is equal to 3. So it is called an condition along with the differential equation. So what is the meaning of this? Y of 0 is equal to 3 and you are going to find the solution of this differential equation. You will get a solution curve. Solution curve means you will get a family of curve. At least one curve passing through this point. Suppose if they give equations like this, y of 0 is equal to 3 and the solution curve in one curve passing through the point 0, 3. So now you are observing the graph. Blue color graph so they are passing through the point 0, 3. Mark is it clear? So that is the idea about this problem. And in mathematics, we call it as an initial value problem. So we'll call it as an initial value problem. Sometimes it will do more than one condition. Y of x naught is equal to y naught. Y of single prime of x naught is equal to y1. What it means? Graph solution curve passes through the point x naught, y naught. Solution curve of this differential equation passes through the point x naught, y naught. At that point, what is the slope? Slope is y1. The slope of equation without drawing the diagram, we will come to know solution curve passes through the point x naught, y naught. And at that point, if we calculate slope is y. I hope it's clear. All right? Okay. So you can draw the diagram and you can verify all these things. Right? Yes, you can calculate, you can verify. Right? Okay. As increase so 0 as x tends to infinity, y becomes 0. Right? You can calculate superposition principle. You can combine the linear solutions. By one combine model. Right? We call it as a superposition principle. So if you have more than one solution, you can combine. So f plus g, f is one solution, z is another solution. You can combine. Right? So here they have given one equation. I have obtained the solution, mathematical solution. Mathematically, then you can draw the graph. Right? So from this graph, you will come to know as W increases, the frequency of the response will increase. So that idea will come to know. We learn actually it is one equation. One equation is converted into 5 equations. I learn simply I have changed the value of omega. First time omega is equal to 1 2 3 4 5 you will get 5 differential equations. I have solved 5 differential equations separately. Then I have drawn the graph using GeoGebra. So what I will come to know that conclusion is, so omega increases, frequency of the response will increase. That idea will come to know. Similarly, I can solve another set of equations, right? You can draw the diagram. You can say that mod of x increases, the magnitude of the response will increase. That idea will come to know from this graph. Again, you can solve another two sets of equations. We'll solve model, right? So totally I have solved 25 equations, not 25 equations, only 5 equations. Simply I have changed the parameter. So now one variable that variable can be replaced by some constants. We'll get a different set of equations. I hope you are going to study integration of f of x dx. So definite integral limits that can be generated in the GeoGebra. GeoGebra generate ಮಾಡಬಹುದು. So what is the geometrical meaning of integration of f of x dx? So you'll get a family of curve, right? In all those curves, if you calculate slope, slope must be same. The slope same. I have calculated the slope -2 ಇದೆ. All family of curves I have drawn I have taken the point on the curve, draw a tangent, calculate the slope, and the slope remains the same. So that is the geometrical meaning of integration of f of x dx. So these things can be generated in GeoGebra. The area under the curve ಅಂತ ಹೇಳ್ತಾರೆ, integration of a to b f of x dx ಅಂತಂದ್ರೆ, so you will say that area under the curve. So ಆಗಲೇ ನಾನು ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡು ತೋರಿಸಿದೆ ನಿಮಗೆ. How we are going to calculate cross sectional area ಅಂತ ತೋರಿಸಿದಲ್ಲ ಹಾಗೆ. ಇಲ್ಲಿ ಏನು ಮಾಡೋದು, you are going to calculate area under the curve between two numbers a and b. Along with the x-axis, you can take any two numbers. You are going to calculate area. So these things can be done very easily in GeoGebra. ಹೆಂಗ್ ಮಾಡಬಹುದು ಅಂತ ಇವತ್ತು 4 ಸ್ಟೇಟ್ಮೆಂಟ್ ಟೈಪ್ ಮಾಡಿಬಿಟ್ರೆ ಐ ಹೋಪ್ ವಿಲ್ ಗೆಟ್ ದಿ ಏರಿಯಾ, ರೈಟ್? ಸೊ ಯು ಕ್ಯಾನ್ ಡೂ ಆಲ್ ದೀಸ್ ಥಿಂಗ್ಸ್. ಸೊ ಇದನ್ನ ಮೆಕ್ಯಾನಿಕಲ್ ಹುಡುಗರಿದ್ರಪ್ಪ ಅಂದ್ರೆ ನಿಮ್ಗೆಲ್ಲ ಯೂಸ್ ಮಾಡಬಹುದು. ಸ್ಪ್ರಿಂಗ್ ಆಕ್ಷನ್, ಸಿಂಪಲ್ ಹಾರ್ಮೋನಿಕ್ ಮೋಷನ್, ಫಿಸಿಕ್ಸ್ ಆಕ್ಚುಲಿ ಮಾಡ್ತೀರಿ, ರೈಟ್? We are going to convert all these things in the form of an equation. Hanging a spring after you'll get a sinusoidal curve, right? So you can calculate the period, altitude, etc., etc. Again, the equation solve ಮಾಡಬಹುದು ಸಿಗಲ್ಲ, ಅಲ್ಲೆಲ್ಲ ಬರ್ತದೆ. Right? You can do all these things. Right? Sometimes we call it as an over-damped motion. All right? So you can calculate, you can draw the diagram. Critically, sometimes we will say that critically damped, right? Under-damped, over-damped. So you can calculate all these things and you can draw the diagram. Sometimes we will call it as a transient and steady state solution. So simply we are going to solve the differential equation. We get the solution. So ಯಾವಾಗ ಟ್ರಾನ್ಸಿಯೆಂಟ್ ಅಂತ ಹೇಳ್ತೀವಿ ಅಂತ you can draw the curve. So you are going to combine steady state and transient state. ಇದನ್ನೆಲ್ಲ combine ಮಾಡಬಹುದು. You'll get a resultant solution that can be obtained. Right? Thank you.
Good evening to everybody. Our respected principal sir, the GB Dhanshat sir, has given a kind permission to have the National Mathematics Day and has permitted to invite Dr. S.S. Benchali sir as a guest lecturer on this occasion. So on behalf of the Science Department, on behalf of the HOD of Science and all the staff members in the institution, first, I am thankful to our beloved Principal GB Dhanshat sir. And Madam Srimati Gadi Madam has invited such an excellent, outstanding guest lecturer, Dr. S.S. Benchali sir. He has given a nice presentation, right from starting the point, line, trigonometry, parabola, and geometry, algebra, and a different new aspects and origin of mathematics day for mathematics subject. So, what is that? GeoGebra from the geometry and algebra. The new era has been started in the mathematics. And recently, the lab also introduced for PUC science, which is a new ideas in mathematics. Sir has given a wonderful presentation subject to all the students in easily understandable manner. On behalf of principal sir, organization, behalf of Srimati Gadi Madam and Sri M.K. Chaudhary sir, coordinator of IST student section, and all the staff members. I'm very thankful and grateful to Dr. S.S. Benchali sir. Yes, sir.
Thank you, sir.
And myself, RTB would be working as a coordinator for faculty section of IST for our BVVS Polytechnic Bagalkot. So, and for arranging such a this guest lecture, our colleague Mr. Santosh Patil has given a complete support of faculty, that is technical support, including the arrangements and three things, that is entire time for all of the students. I am thankful to colleague Sri Santosh Patil sir also. And all the staff members of science department, they have contributed to give the seminar, this guest lecture to all the students, which is beneficial for their knowledge. They have such a development, progressive, new ideas for our students. So I'm very thankful on behalf of the organizers to one and all who have contributed their efforts directly or indirectly. Thank you, one and all. Thank you, sir.
I take this opportunity to thank the principal of this prestigious institute, as well as I want to thank the dean madam and Thank you very much.
Thank you, sir.
Thank you, sir. Thank you very much, sir.
Thank you very much, sir.